Hello everyone, welcome to Robert Morris University Math 0900 Chapter 4, Lesson 3. In this lesson we are going to recognize polynomials and determine their degrees. We're going to learn how to add and subtract polynomials and also learn how to evaluate and predict a value. There are a lot of new terms for this section, so please review this list and make sure that by the end of the lesson you are familiar with each one of those terms. Polynomials are expressions that are made up of more than one term. And remember, we've been dealing with terms throughout this entire course so far. A term can be something like 2x or the number 3, or just the plain or a variable such as y squared. The terms are the items that we string together with our plus and minus signs. When we start to string those terms together and we have more than one of them that are put together in the form of ax to the n power, where a is a real number and n is a whole number, then that means that we now have a polynomial. Remember that the prefix poly means many, so that means that we're dealing with many terms. Polynomials should always be written in decreasing order according to the power of their variable as the polynomial reads from left to right. This is also referred to as descending order. And you guys have actually heard me say that a couple of times throughout this course, that when we have had simplification going on, I have reminded you that you should always have your biggest power of x be written first, and then the second largest would come next, the third largest would come next, and so on and so forth. That is good algebra, and that's how our polynomials should be written, and that is called decreasing order. And you'll notice that that's actually one of our vocabulary words up there. Now, the polynomial that we were just looking at, the 5x cubed plus 3x squared minus 2x minus 5, that's just a plain old polynomial. You'll notice that we're just dealing with one variable, and that's the variable x. Sometimes our polynomials will have more than one variable in it, and when that happens, that is referred to as a multivariable polynomial. And the reason that we call it a multivariable polynomial is because it has multiple variables. And those are the polynomials that have more than one variable in it. So you'll see we have 5xy plus 8. Another example is 2x squared minus 7xy plus 9y squared. So just note that polynomials can have a single variable in it, or it can have multiple variables. It just depends on what our situation is. It's also going to be necessary for us to find what's called the degree of each term. And the degree of the term is the sum of the exponents of all of the variables for that particular term. If you look at the example 7x cubed, the exponent is 3. Therefore, the degree of that term is 3. That term has a degree of 3. The next example, we have 4xy. This one has a degree of 2 because the x has a variable of 1 and the y has a variable of 1. So when you, it has exponents of 1. The x has an exponent of 1 and the y has an exponent of 1. So when you add your exponents, it has a degree of 2. And then the third example that we have 10x to the fourth y squared. When you look at the exponents that are associated with your variables, we have a 4 and a 2. So 4 plus 2 gives us 6. So that example has a degree of 6. Now, the purpose of this is so that we can determine what is referred to as the degree of a polynomial. The degree of a polynomial is found by identifying the highest degree of every single term within a polynomial. So if we move to the next page and look at our first example, you want to look at every single term within that example. So we have 5x cubed, that's our first term. Its degree is 3. The next term is 8x squared. Its exponent is a 2, so its degree is 2. The next term is negative 20x. That variable has a degree of 1. And then the last term is just a constant. There's no variable term associated with it, so its exponent would be 0. So the degree of that term is 0. So the largest degree that we identified was a 3, which means that the degree of the entire polynomial was a degree of 3. The next example, we have to look at each individual term separately. And there should actually be a plus sign in between those two terms, so I apologize. So we look at 6xy. The x and the y both have exponents of 1. So you would add 1 and 1 to get 2. Then we have 4x squared y. So we want to add our 2 and the 1 that's associated with the y to get a 3. And then we're going to look at 2xy cubed. The x has an exponent of 1, and y is cubed, so 1 plus 3 is 4. The largest degree of each one of those terms is a degree of 4. Therefore, the degree of the entire polynomial is a degree of 4. So just a special note here that says that a polynomial that consists only of a constant is said to have a 0. We did touch upon that here whenever we talked about the number 2 having a degree of 0, and the reason for that is that there's no variable term associated with a constant, and since there's no variable term associated with that, that means that the degree of that term has a 0 because there's no exponent to accompany the variable. So the next topic that we're going to look at are special types of polynomials. We can classify our polynomials into special types that we will work with frequently. Now, we did mention that the prefix poly meant many, thus indicating that we generally are going to be dealing with many terms. But that's not always true. One reason is that we have what's called the monomial. And a monomial is a special type of polynomial in which we only have one term. Those monomials are terms such as 5a, 3x cubed, y, z to the fourth, 12xy. You'll notice that in these monomials, your terms have no separation with plus and minus signs. Please do not be confused, however, by a monomial that might be written such as negative 3a. That's just simply a negative monomial. The next special type of polynomial is the binomial. The binomial has two terms, as its prefix might lead us to believe. So you'll notice we have 7x plus 9y. So that separation there of that plus sign shows us that we have two terms. Negative 6x minus 4. We have the separation with the minus sign, but that breaks into two negative terms. We have negative 6x, that's our first term, and our second term is negative 4. When we put them back together, we read that as a string of subtraction. Just like our first problem, we have positive 7x and positive 9y. Those are my two terms, but when I put them together, I simply read them as addition. And lastly, I have 5x to the fourth plus 2xy squared. And my two terms are positive 5x to the fourth and positive 2xy squared. The last special type of polynomial that we have is called a trinomial. The prefix tri is indicating that we're going to be dealing with three terms. So an example here is 8x squared minus 7x plus 4. Please note that we string our terms together and read it as addition and subtraction, but when we look at the individual terms, we keep those plus and minus signs with the term. So positive 8x squared, negative 7x, and positive 4 are the three terms. The next example, 2ab cubed minus 6ab squared minus 15ab. When we put them back together, when we look at them individually, we have the positive 2ab cubed, negative 6ab squared, and negative 15ab. And then lastly, we just have one more here. We have 2 plus 5y plus y to the fourth, and that gives us three positive terms there. So what we're going to do now is state the degree of each of the polynomials written below, and we want to state also whether it is a monomial, a binomial, or a trinomial. So why don't you go ahead and pause the recording, identify its degree, and what type of polynomial it is. Go ahead and pause the recording now. When you're ready, hit play. Okay, by now everyone should be ready to check the answers to A, B, and C. For letter A, you should have identified that the first term here had a degree of 2, and the second term had a degree of 3. Therefore, the degree of the entire polynomial was a degree of 3. And since it had two terms, it is a binomial. For letter B, it has a degree of 7 because 5 plus 2 is 7. And it is only one term, therefore it is a monomial. In letter C, the first little term here has a degree of 4, the second term has a degree of 1, and the third term doesn't have any variables, therefore it has a degree of 0. So the largest degree is a degree of 4, therefore the degree of the entire polynomial is a degree of 4. It does have three terms, which makes it a trinomial. A trinomial. Now for the next section, we are going to learn how to add polynomials. Polynomials can be added, subtracted, multiplied, and divided. We're going to start with addition. And what I need you to remember for this section is that we are simply going to combine like terms. Now, when you have a group of parentheses, the first thing that you should be thinking is, can I do anything inside my parentheses? As you look at both groups, you will notice that we can do nothing inside. So we need a strategy to help us to remove the parentheses so that we can add our polynomials. When you have nothing in front of a group of parentheses, you are permitted to simply remove the parentheses and rewrite your expression. Those parentheses were simply there for cosmetic reasons to show you that that was a polynomial that belonged together. Similarly to having nothing in front of a parenthesis, when you have a plus sign in front of your parenthesis, you can just simply remove the parentheses and bring down what's inside it. If your term was positive, you would want to bring down the plus sign. But since my term is negative, I'm going to go ahead and bring down the negative 3x. And now we have a string of addition and subtraction that we can do and combine like terms following the rules that we were taught. So I'm going to start with my x squareds so that my polynomial will be in descending order. So I have 5x squared minus 3x squared, which will give me 2x squared. And I will cross them out so I know I've used them. Then we have negative 6x minus 9x. And that is going to give us negative 15x. Cross those out so we know we've used them. And then lastly, I have negative 12 plus 5, which will give me negative 7. Always check just one more time to see whether or not you can combine like terms or do anything else. And at this point, there is nothing further that we can do, so our answer is as simplified as it can possibly get. Example 3 is going to be very, very similar. We are going to want to remove our parentheses and add our like terms. I'd like for you to go ahead and try this problem. When you're ready, go ahead and hit play, and we will move on together to check our answer. Okay, by now you should have had an opportunity to complete example 3. And we're going to go ahead and go over the answer for that. Since there is nothing in front of our first parenthesis, we can simply rewrite it as 1/2 x squared minus 6x plus 1/3. And since we have just a plus sign in front of the second parenthesis, I can bring down everything else that's on the inside. So I'm going to write that as plus 1/5 x squared minus 2x minus 1/2. And now I'm going to work on combining my like terms. The first thing that I need to do is get a common denominator for my x squareds. So the common denominator that I need is 10. So I am actually going to write these beside each other. So to go from 2 to 10, I had to multiply by 5. So that gives me 5/10. And to go from 5 to 10, I had to multiply by 2. So that's going to give me 2/10 when I do 1 times 2. Then I'm going to group together my x's. So I have negative 6x minus 2x. And then lastly, I see that I'm going to have to gather my constants together, but they are also fractions. So I'm going to need a common denominator for my 3 and my 2, which is going to be a 6. So I'm going to go ahead and write my fractions as a plus something with a 6. To go from 3 to 6, I multiplied by 2. So 1 times 2 is 2. And then I have a minus something with a 6. To go from 2 to 6, I multiplied by 3. So that gives me 3/6. We are now prepared to simplify everything in this expression. So 5/10 plus 2/10 gives us 7/10 x squared. Negative 6x minus 2x gives us negative 8x. And then lastly, we have 2/6 minus 3/6, which gives us negative 1/6. Always check to see if there is anything else that can be done. You want to check for any further like terms, any further combining, and you want to make sure always that your numbers are in descending order. So that is the final answer for example 3. At this point, I would like for you to go ahead and do example 4. Please pause the recording and press play as soon as you are ready. Okay, everyone, by now you should have had an opportunity to complete example 4, and you should be ready to go ahead and go over the answer for it. Soon as we turn the pen back on. Okay. So to remove the first set of parentheses, we do not need to do anything since there's nothing written in front of it. So we're simply going to rewrite everything that is on the inside. As soon as I move the little problem right back up. Okay, so we have our 5.6 and plus 5. Since there is a plus sign in front of the other parenthesis, we do not have to do anything special to remove that one either, so we're simply going to write minus 3.4x cubed minus 1.2x squared plus 4.5x minus 7. Now we are ready at this point to start combining all of the like terms that we see. So we're going to start with our cubed terms. So we have 1.2x cubed minus 3.4x cubed. And you should get negative 2.2x cubed. Then you're going to move on to your squared terms. Cross those out. We have negative 5.6x squared, negative 1.2x squared. So we have negative 5.6 minus negative 1.2, and that is going to give us negative 6x 4.8x squared. Cross those out so that we know that we have used them. Keeping with descending order, we are next going to look for any x term. There is only one, so we will simply bring down 4.5x. And lastly, we look for any constants. And we have 5 plus -7, or just 5 minus 7, which is -2. And that there is your final answer. Everything is written in descending order, and all terms have been combined. Okay, everyone, we are now going to move on and learn how to subtract polynomials. Subtracting polynomials requires you to distribute a negative through your quantity. In other words, what we're going to do is change the sign of every single term that is in the quantity that we're distributing to. So as you look at this first example, you'll notice that there is absolutely nothing in front of the very first parenthesis that we have. We can't do anything inside that parenthesis, so I'm simply going to rewrite all of those terms. I have 7x squared minus 6x plus 3. However, for the next set of parentheses, we have a minus sign in front of it. That is like having a negative quantity, and that requires us to distribute that negative to every single one of those terms, which will flip all of their signs. So my positive 5 will become a negative 5x squared. My negative 8x will become a positive 8x. And my negative 12 will become a positive 12. Now that you have distributed that negative through your quantity, you are now ready to combine like terms and simplify that expression just like we have done in every other example so far. So at this point, let's begin simplifying. We have 7x squared minus 5x squared, which will make 2x squared. We'll cross out our largest powers. Negative 6x plus 8x makes positive 2x, so we write plus 2x. And then we have 3 plus 12, which makes positive 15, so we write plus 15. Cross those out, and we now are assured that we have used every single term, and we are ready to move on to the next problem. We are going to do this exactly the same way. I would like for you to go ahead and try this problem. Please pause the recording, and as soon as you're ready, we will check the answer together. Okay, everyone, by now you should be ready to check your answer to number 6. As you look inside both of your quantities, you should see that you have no like terms, so you cannot simplify anything. So you must, at this point, use your strategies to remove the parentheses. To remove the first set of parentheses, we do not have to do anything because there's nothing in front of them. They're simply cosmetic to show separation for the polynomial. So we're going to rewrite it as negative 6x squared y minus 3xy plus 7xy squared. For the second set of parentheses, we must distribute in the negative. So once we do the distributing, we will have negative 5x squared y plus 8xy plus 15x squared y squared. The next step is to look for anything that is considered a like term. So we're going to start with x squared y's. The only other x squared y that we have is this one. So we have negative 6 minus 5, which gives us negative 11 x squared y. I'm going to cross those out so I know I've used them. Next, I will move on to my xy's. I have negative 3 plus 8, which gives me positive 5 xy. And I will cross those out so that I know I've used them. And lastly, I have xy squared. And I have no other xy squared, so I will simply rewrite 7xy squared. And you will notice I have one more term, so I must bring that down as well. Positive 15 x squared y squared. And this here is your final answer. Our last topic for today is evaluating polynomials to predict a value. Polynomials can be used to represent real-world situations, and therefore they can be used to predict values. In these cases, polynomials must be evaluated. We don't want to just leave them in the form as we have done up here. We have to actually carry through with the math and get an actual answer. So let's take a look at example 7 here. It says that automobiles sold in the United States have become more fuel efficient over the years due to regulations from Congress. The number of miles per gallon obtained by the average automobile in the United States can be described by the polynomial 0.3x plus 12.9, where x is the number of years since 1970. Use this polynomial to estimate the number of miles per gallon obtained by the average automobile in 1972 and 2012. So, the way that we would use this polynomial to help us out with this problem is first we're going to write it 0.3x plus 12.9. We need to remember that x is the number of years since 1970. If we are evaluating for 1972, we need to figure out how many years difference there is. So we're going to start by subtracting, and we'll get 2. That means that we're going to plug 2 in for x and actually evaluate that polynomial. So 0.3 times 2 gives us 0.6 plus 12.9, and when we simplify there, we're going to get 13.5. That tells us that in 1972, the average automobile got 13.5 miles per gallon. Now, I would like for you to go ahead and try letter B. Follow the same steps. Press pause as soon as you're ready. Please go ahead and press play. Okay, by now you should be ready to check the answer for letter B. Whenever you set up the subtraction problem to figure out what x was, you should have found that 2012 minus 1970 should have given you 42. So that means that you are going to plug 42 in for x, and you are going to evaluate that polynomial. So 0.3 times 42 is going to give you 12.6. And 12.6 plus 12.9 is going to give us 25.5. And that means that the average car in 2012 is getting 25.5 miles per gallon. This concludes our lesson on Chapter 4, Section 3. If you have any questions about any of the content that we covered in this section, please feel free to contact me and I will be more than happy to answer your questions. Thank you.